All right, so questions. How is PA4? So hopefully people are pretty far along with assignment 4. Hopefully people have been working steadily on PA4, let's put it that way. Even if you don't feel like you're far along, hopefully you've begun it and are working on it and not waiting to start. So I posted an announcement on Canvas this morning, so I checked yesterday at GitLab for repositories, and I only found about a quarter of the students in 224 have actually created a repository and given me access to it, which is potentially disastrous comes Friday when I try to grade your assignments. So I made a deal with you in the announcement. If you, I don't remember what the detail was, if you have not already created a repository, or if you have and you're not sure that it worked, if you want to know where you stand with it, right, make yourself a repository and send me a note before 5 p.m. today and say, I have my repository up there, can you let me know if you can access it? Okay, if you already know that you're doing it right and I'm set up, don't worry about this. But if you're not sure, if you have any doubts, set your repository up before 5 o'clock today. Send me a note and say, can you let me know if you can access it, and I will let you know. Okay. And really, you should be doing this on day 1, right? It takes 4 commands, especially if you're starting from scratch. It's harder once you've already got a directory structure and a local Git and all that. That's where most of the problems happen. If you're starting from scratch, make a directory, it takes 4 commands. Git init, git commit, git add, git remote, add origin. And you've got your repo. And then just do your git push. So 5 commands. So if you want to make sure of that, do that before 5 o'clock today. I'm going to be offline all of tomorrow, as far as I know. I should be back Thursday, but I don't want to start going through repositories one by one Thursday with people trying to figure out if the repository is there or not. So please do this today if you feel like you want to double check it. All right, any questions or concerns about that? And it's the same procedure that you did for the homeworks and for the other PAs, right? Just make a new repository. It's got to be called index uppercase I, not PA4. It doesn't matter what you call the directory, right? But the repository on GitLab has to be index. Yeah?
Is there a particular name you want us to GCC the program to? Like, should be indexed with a capital I too?
I think it was indexed with a lowercase I, but let's see. Does anybody remember?
The repository should be uppercase.
The repository is uppercase. The program name itself,
Sorry.
I thought it was lowercase I index.
I think it is too. I don't see it in here.
I didn't see it either.
I don't see it. Just make sure you include a makefile, and your makefile will make your executable, whatever you call it. All right, so I posted a grading rubric for PA4, and this is approximate. I may have missed something, but most important thing, make sure code's readable by 8 a.m. Friday. Okay, I'll dock 25 points if it's not in that batch that I downloaded 8 a.m. And I will let you know by Canvas email by 10 a.m. Friday. I know I said don't use Canvas email, but that's the only way that I can send emails out to you, because I don't have your email addresses otherwise. So I'll send you Canvas mail before the start of class Friday, and let you know if I could not read your repository. And then you're down 25 points. I'll make another download Saturday morning at 8. If it's not in there, you'll be down a total of 50 points. I'll make a final download Sunday morning at 8. If it's not in there, you're down 100 points. Okay, so make sure you get your emails in a timely way. And then Friday is the time to say, hey, I don't know how to make my repository accessible, and we can work on that in between classes and such. The other big deduction is if your code does not compile, or if it doesn't do anything. Okay. And then there's other things. So if your name's not in the comment block, that's 10 points. If it's not well commented in general, it's 10 points. Makefile is worth 10 points. A makefile with errors will cost you 5 points. And then just some things, and this is where there might be things that go beyond here. But some things, right, having extra stuff in your phrases that shouldn't be in there, not converting things to uppercase, not ignoring those characters that should be ignored, not treating new lines as spaces, and so on. Recording empty phrases, and that's a special case you need to check for, right? An empty phrase with nothing in it does not count as a phrase. So those are all 5 points. If the tallying's not working, that's 10 points. If there's no tallying being done at all, that's 15. The sort's worth 10. War and Peace test is worth 5. So, because that's a harder one to make work. But that's a rough guideline of how I'll grade. So you can look that over and ask questions if you like. All right, any other questions, issues? So assuming that you're working on a super duper get car, or that you finished a super duper get car, where do you go from there? We flow charted some of the other things like phrases and so on, but practically speaking, where do you go once you've got your super duper get car working, right? Test this in a main program. Just call super duper get car in a while loop until it returns end of file, and just print out what it gives you. And you can feed that an input file, and it should give you an uppercase version with no new lines, just spaces and no parentheses, quotes, dashes. But once you've got that, I would say write something like get phrase. Right, so this is a series of while loops. A while loop which looks for the beginning of a phrase, and then a while loop that looks for the end of a phrase, and while it's looping is storing the characters it reads into an output array. Okay, so look for the beginning of a phrase and then loop and save while looking for the end of a phrase, and then add a null terminator to the phrase and return that. And if you make that something like a get phrase function, you can make a main program that just calls get phrase repeatedly and prints out the value of the argument. And if you throw War and Peace at that, you should get a nice printout of War and Peace broken into phrases, one per line. And that lets you debug this function. Right? Once that's working, then you can go ahead and make this save phrase. It takes the dictionary and the phrase that you just discovered and stores it in the dictionary or updates the count of the number of times that phrase occurs in the dictionary. And once you've got get car and get phrase and save phrase working, right, you've got the main loop in the main program done. And then the trick is, once there's no more phrases, well, you need a way to detect that. So maybe have this return an int, which is like 0 for success and EOF for the end of the file. Now just loop get phrase, save phrase, get phrase, save phrase over and over and over until you hit the end of the file. And then go ahead and do your print. And if that works, then go ahead and write your sort. And then do your sort before your print. So I'm a little unsure where people are with this, because I've got some people who have been coming to me and asking questions about this, but the majority, I haven't really heard a lot of questions. And so I don't know if people are proceeding confidently and making progress, or if people are at the beginning and unsure how to start, or somewhere in between and are stuck. And I don't know how to interpret that. But if you are not proceeding confidently, right, let me know soon, like today, if you're stuck or you're unsure how to go forward. Otherwise, I'm going to assume you're proceeding confidently.
Yeah, can we talk about sorting algorithms? Because like my bubble sort keeps, like, it works fine, except for sometimes it misses like the lower characters if I sort one way. It's
What do you mean misses the lower character?
well, so like it'll save one version of and it's in the sorting, but it'll only save one and only save one, and that's if I sort it by top down. If I sort it by bottom up, I guess it saves all of them. So I know that it's not in the temporary; it's in the sorting. And I don't know if I'm.
So you say saving one version of and. What
Yeah,
does
so
that
like when I
mean?
run the final, how many times does this phrase show up?
Mhm.
It just says one on and. But if I sort it differently, it says all of them, which is like
So-
104 or something.
Yeah, so,
Did you sort your category?
yeah. Remember, we've got parallel arrays if you're not using structures. We've got an array of 1,000 strings, we've got an array of 1,000 integers. So in your bubble sort, when you want to swap two elements, make sure you swap them not just in the dictionary but also in the count array.
Okay.
So a pair of swaps.
Okay. I am using a structure, so I'll modify it later.
Okay. If you're using a structure, yeah, it should carry it over.
That's what I would be thinking. And I even tried to, because I was just saying a temp was, I equals temp, and then j equals I, and I equals temp. But I even went through and made sure that the integer was saving and the phrase,
Mm-hmm.
and even that wasn't working rather than just setting them equal. So
Okay.
it probably has something to do with my bubble sort being weird, but I might just need to talk to you after class.
Okay. You can also throw in tons more print statements, right? Before you sort, print out the two things you're about to swap. All the pieces of the structure for I and I plus 1. Do your swap and then repeat that print. Print out the new pieces of the structure for I and I plus 1. Make sure nothing's getting dropped there.
Okay, that might work.
Okay.
Because there's just so much in War and Peace that's what I'm trying to.
Oh, yeah, that's a hard one then.
Yeah, because it's working on index sample fine.
Okay, if it's blowing up on War and Peace, this is a general thing, right? War and Peace will test your handling of array overflows, right? If you set up your dictionary to hold 1,000 phrases, but you accidentally let 1,000 first phrase into dictionary, it will step on something else in memory. And the way I've declared this, it might actually step on my count array, and I could suddenly find counts going wonky. So one way to look at that is any time that you do anything with dictionary, before you write anything in a dictionary bracket I, print out the value of I. Or do a check and see if I is bigger than 999, print out, danger, danger. Throw in some bounds checking like that. Because if something's only going wrong on War and Peace, it could just be that, it's a better test case, but it's more likely it's something going out of bounds. And that's part of why it's a good test case to use. So this is not related to PA4, right? We're moving beyond PA4 now. But I wanted to talk about this idea of integer bracket bracket versus integer star star. And these are not the same thing, even though we kind of treat these as the same. Right? This is an array of 5 integers. This is an array of integers, and if we point it to an array or some spot that holds 5 integer-sized things, they'll both be arrays of characters. And if I say, integer star a, I can say a bracket some index, and it works exactly as if I said integer a bracket 5. So we think of the star and the brackets as being interchangeable, right? They're really not. And really, I only want you to use brackets when you really mean, an array, preferably of a fixed size. And if you just want something that points to an integer or a character or something, use the stars. So here's a piece of code that shows you examples of both. A is declared to be integer a bracket 5 bracket 5. And when you do that, here's what happens in memory. Okay, so A points to somewhere in memory. And at that location, you find this element, followed by this. Followed by this. Followed finally by 4, 4. You find 25 spots in memory, each containing an integer. And the first one corresponds to element 0, 0, the next one is element 0, 1, and so on. And they're just laid out one right after the other. So let me do this. Let me set element bracket I bracket j to 10 times I plus j. So we can, if we see a 23, we'll know that's a bracket 2 bracket 3. And in the second chunk of code, I'm making an integer star star. And what I'm doing is I'm populating each of these elements with an array of 5 integers. And loading the array accordingly. So let's run this. So let's print out A. Okay. So GDB is smart. It tells me this is what A is. It's an array of five element arrays. But if I print the address of A, this is where A is pointing. Okay. And if I examine in decimal this location, it's got a 0, 1, 2, 3, 4, 10, 11, 12, 13, 14. Right, so these are stored sequentially in memory, right? This is the memory address on the left. It goes up by 4s because it's 4 bytes per integer. And these 25 numbers are just stored sequentially one after another. Now if I look at B, B is this address. And if I examine that address, I do not find the first element of my array. I find a weird number. If I examine that in hex, what I discover is it's a memory address. So A is actually pointing to the first element of my two-dimensional array, but this B is pointing to an address. And the next location in memory is another address, and another address, and another, and some other stuff. So when I say integer star star, I have a series of addresses sitting at B. And if I look at what's at this address, which is what B is pointing to, so it's this one. Right, there's my 0, there's my 1, 2, 3, 4. If I look at what B is pointing to and I look at the next address after that, that's going to be the address where B bracket 1 bracket 0 is stored. And it may not be right after this. So this is really saying that B is a pointer to an integer array, which means it's an array of pointers. And so B, first element in the array, is a pointer. It's an address, followed by another address, followed by another address. So it's fundamentally different from this thing, which is why in PA4, when I said you can declare your dictionary to be 1000 by 201, I said you can assume those dimensions are fixed. This is what you want to use everywhere. If you try to pass your dictionary to a sort function, and in your sort function you say, I'm expecting a character star star, it's not going to do the same thing. Okay, it's going to get tripped up. So you've got to do it like this everywhere, or almost nowhere. Right, so my suggestion is just always make your dictionary that. Always make your count array 1000. But one-dimensional array, if you pass it as an integer star, that's going to work too. But for 2 dimensions, it's a different game. We'll demystify that in 222. But for now, just make everything hardwired. Alright, so we're changing gears. So, time to talk about regular expressions. And you'll see these called just regexes. And there's this command I've mentioned called grep. You can say grep and you can type in a string and you can type in a file and it will search that file for that string. So if I want to find every occurrence of the word int in my file go.c, I can just say grep int go.c, and any line that has the string int somewhere on it, it'll get printed out. So grep is a simple search function. And you notice, of course, it found int inside print, so it printed out this line. Right, it's just a straight I followed by N followed by T. So the RE in grep is regular expression. Grep is a way to play with these things. But we can use grep just to search for a string. Okay, so let's go inside VI. And do you remember how to search for something inside VI? So slash. So if I say slash int, it'll take me to the first spot where I find int. And if I hit an N, it'll show me the next occurrence. And each time I hit N, it takes me to the next occurrence. And if there's nothing left from that point in the file down, it'll wrap around and find an occurrence starting from the top. Okay, so we can do a slash to search, and we're going to do this inside VI, but eventually we're going to learn about a utility called sed. And what we're doing in VI right now, we can do outside of VI using sed, but it's easier to play with in VI. So if you say slash and you type in some pattern that searches for that pattern. Okay, suppose we want to do some editing. We can say colon substitute slash old slash new. And that will look on the current line for this old pattern, and if it finds it, it'll replace it with a new pattern. So let's say I wanted this to be an uppercase int for some reason. I'm switching to a new compiler, and int has to be uppercased. So I can say colon substitute slash int with uppercase int. Let me make it all uppercase. And that should look on that line. If it finds an occurrence of int, it should replace it with, in this case, uppercase int. Right, so int changes like that. Or maybe I want doubles. So I can say substitute int with double. And now it says for double I equals 0. Alright, we can also say something like colon number comma number, substitute old new, and say do the substitution on any lines between this first number and this second number. So maybe I want to do the substitution on the first 14 lines of my program, so I can say colon 1 comma 14, substitute int with double. And all those occurrences down to the line that I'm currently on should get replaced accordingly. I spelled W wrong. And you can do a U to undo. I was on the first line. 1 comma 14. And your first line is always line 1. If you want to use the last line in this statement, you can use a $sign. We know the first line's always line 1, but the last line depends on how big your file is. But you can use a $sign to represent the last line. So if I say :1, $, substitute int with double, that does it everywhere, including in the middle of my print statement. Well, I didn't want to change my printf into a per double f. So I could do something like this: :1, $, substitute int space with double space. And as long as every time that I actually use int, I have a space after it, this should just pick up those ints. So now I've changed all my ints to doubles without perturbing my print. Global substitutions are usually pretty risky to do, especially in a big file. If you want to change a variable name, right, like I don't like my variable I, so I'm just going to change I to index. Well, that's probably a bad thing to do, right? Because my I in void got changed into index and stuff like that. Yeah?
I can see the risk of this because you didn't change the size of int.
Mm-hmm.
And int didn't change.
Right, right. So we're not usually going to do reckless global substitutions. Having a hard time coming up with random names. I'll do my name. All right, so we'll pick on some names. So here's something I bump into a lot. I have a list of names and I want to change this into first initial followed by last name. In other words, I want to change this to J. Smith, B. Jones, M. Smith, N. Macias, and B. Flintstone. And I can do this with one command in VI. It's a special command though. So let me show you how to do this first, and then we'll talk about it. Here we go. Okay, so this is where regular expressions come in. And we're going to spend a few days doing this. So regular expressions are a combination of two things. One, it's being able to look for a certain pattern. And then it's replacing some piece of that pattern with something else. If I want to change this to be just J. Smith, B. Jones, M. Smith, what I want to do is find everything starting with the second letter up through and including the first space, and I want to replace that with nothing. I want to get rid of it. So I want to do something like this. I want to find the first character, and then I want to find a set of characters up to and including the space, and I want to get rid of all of that stuff. I want to replace it with nothing. But I still want to keep this first character here. Alright, so there's some other things we can do in our search pattern. suppose I want to find an uppercase B. So let's go up to the top of my file here. I can say /B, and it'll find the B in Barbara Jones. And if I search for the next pattern, it'll find the B in Betty. If I search for the next one, it'll find the B in Bauman. Suppose I want to find a B at the beginning of a line. I want to pick up Barbara and Betty, but not John. So I can use a caret to say the pattern that I'm looking for begins at the start of the line. I want to find a B right at the beginning of a line. So that'll find Barbara Jones, and it'll find Betty Flintstone, and if I search again, it'll wrap around and find Barbara. It does not find the B in Bauman because it's not sitting at the beginning of a line. So this is our first special character, and it's called an anchor. So a caret says beginning of the line. And suppose I want to search for something at the end of the line, like an E at the end of the line. If I just do a /E, it's going to find Jones, it's going to find Betty, it's going to find Flintstone. So I can search for an E followed by a $. $sign is an anchor that says end of the line. So searching for E $, will only find an E if it's the last character on the line. So that just finds Flintstone. And if I search for the next, that's the only one it finds. So that's our other anchor, is a $. And that's the end of the line. And if I search for something, just a set of letters, it just searches for that combination of letters. So if I search for ON, it finds the ON in Flintstone, it finds the ON in Jones. Suppose I want to find any character followed by an N. So I can use a period to say any single character. So I can search for any character followed by an N, and that'll find IN in Flintstone, it'll find ON in Flintstone, it'll find HN in John, and so on. So a period match any single character. And when I say character, I don't mean letter, I mean any character. Yeah?
And say if you do actually want to search for these characters, do you just backslash before?
Yeah, if you want to search for a dot, use a backslash in front.
Okay.
So how can I find all the names that have a 4-letter first name?
Just four dots in a space.
4 dots in a space. So it finds John, it finds John. It finds B-A-R-A in Barbara, because that's 4 characters followed by a space. So throw an anchor in the beginning. So an anchor, beginning of the string, 4 characters, and a space. There's Mary, Nick, John, and John. Cool. All right, we can also use an asterisk. And an asterisk says match 0 or more of the previous character. So if I search for a C followed by an asterisk, it's going to match 0 or more occurrences of the character C. And it finds that right there at the beginning of my string, because a B is 0 occurrences of the letter C. And in fact, this will match everything. Let's go back to the beginning here. Okay, so it matches an A, it matches a B. If I say search for this again, I'm looking for 0 or more occurrences of the letter C. It finds it sitting right there. If I search again for 0 or more occurrences of the letter C, it takes me over to my D. So there's a potential ambiguity. If I say search for any number of the letter C in a row, right? Well, it could just return 1 C, it could return 2 C's, could return 3 C's, right? So how is it going to decide what matches that pattern, C star? Regular expressions are greedy. They try to match as much as possible. So if I say substitute C followed by 0 or more C's with just an uppercase X, that's going to take that first collection of C's and it's going to replace that whole thing with my uppercase X. Okay, it's going to consume as much as possible. That'll be important in a while. Okay, suppose I wanted to find 3 or more C's in a row on this line. So I need at least 3 C's, and I want that to be followed by 0 or more additional C's. This will match 3 letter C's followed by 0 additional C's, 1 additional C, 2 additional C's, and so on. So if I search for that, the first thing it will find is this collection of, I think, 5 C's up there. If I say next, it'll find this next collection of C's. If I say next, it will skip those 2 C's, because that doesn't match the pattern 3 C's followed by 0 or more C's. So it goes back to the beginning. So when we say colon substitute slash old slash new, it does one substitution on the line. So if I say substitute CCC followed by 0 or more with an X, it only does that in the first time that it finds that pattern on the line. If I want to do a substitution everywhere on the line that's possible, I can put a G at the end of my last slash, and that says do this globally across the entire line. So now both of those batches of consecutive C's should each get replaced with a single X. If I want to replace all consecutive C's with a single X, I could just search for a C followed by any other number of C's, and that should match 3 things in my line, the 3 sets of consecutive letter C's. So I should end up with 3 X's in those places. If I say substitute dot with X globally, well, the dot should match the first letter A. That should get replaced with an X. The B also matches a dot because that dot matches anything, so that should get replaced with an X. And this should just change my line into a bunch of X's. If I say substitute dot star with an X, well, dot star says 0 or more occurrences of any character. Well, that should match the A, followed by the B, followed by the C, followed by the whole thing. That whole string corresponds to the pattern dot star. So this should replace the entire string with just the letter X.
How can I just do change in that one line and don't affect?
So I'm just doing colon substitute. If I do colon 1 comma dollar substitute, then it does it on all the lines. Yeah.
In those earlier examples, when you were doing the line range,
Mhm.
was it only substituting for the first occurrence in each line?
Yeah, unless you put a G at the end.
Okay.
So if I say colon 1 comma dollar substitute dot star with an X, right, that replaces every line with just an X. Okay, so what I'm doing is I'm introducing pieces of regular expressions. There's anchors, beginning of the line and end of the line. There's a wild card that matches any one character. There's a star which matches 0 or more of whatever we put before it. And that's almost all we need to do most of the regular expression things we're going to do. This will be enough to match pretty much any pattern that we want. Regular expressions you can buy whole books on, right, on how to write them. And if you go online, you will go down a big, big rabbit hole, okay? But really all we need is anchors, a period, a star, and probably 3 other things that we'll talk about Thursday. And that's going to be enough to do things like, you know, change this file of names into first initial, last name, or change it into last name, comma, first initial, or all sorts of things like that. So we'll develop this language of regular expressions more on Thursday, and we'll play around with it in VI, but then probably next week we'll start talking about this utility called sed that lets us basically write a program that describes a series of manipulations we want to make on an input file. And it's a really useful way to sort of pre-process input and to do things like breaking a file up into phrases, for example. We could do that very easily with regular expressions, and we'll play around with that later. All right. So mainly keep going on PA4. Push your repo over if you didn't already, right, and shoot me a note this afternoon and say, I think my repo's there, you should be readable. As a reporter, let me know if it worked or not, and I'll give you feedback. All right. No class for me tomorrow. I will see you on Thursday.